In this tutorial, we will compute the total dose rate from trapped protons in a polar orbit. Begin by creating a new project. Enter a project name. Next, enter an optional description. Optional contact information, and optional report header. The project folder is created in Documents. The first step defines an orbit. We define a 600-kilometer polar orbit. Change the file name if you want. And enter a title to describe your computation. Set the apogee and perigee to 600 kilometers. Set the inclination to 90 degrees. Choose mission duration of 75 days and 1 point per minute for good coverage. Click Execute to run the calculation. The result is represented by the orbit token. Visualize the orbit in rotating coordinates to check coverage. Animate to verify the orbit parameters. The second step evaluates peak proton flux. Once again, enter file name and title. Select the orbit from the database. Choose peak flux for this example. Click Execute. The calculation is finished in a few seconds. The point of peak intensity is displayed on the tooltip as well as on the status bar. List the peak flux in HTML or text format. Or draw a plot. In the third and final step, compute a dose depth curve. As before, enter a file name and title. Choose the trapped proton flux from the database. Select intervals of 1 mil aluminum shielding. Choose dose per minute. Plot the results to show how dose rate varies with shielding. Extend this result to another orbit by cloning. Increase the altitude to 1,000 kilometers. cloning copies all 3 tokens and recalculates with the new orbit parameters. Plot the new results to compare. At 1,000 kilometers, the dose rate is 5 times higher.